Students, in this class we will learn about the most important library function, which is actually a built-in library function available in Python, and that would be learning about the math module. Now, in the math module we got scores of functions available to be utilized. Now it becomes important and imperative for anyone knowing Python to have a grasp of how and what these functions are. So when I say what, of course it's explanatory. What are these functions? And subsequently you need to know how. When I say how do you literally use these functions? So that's exactly what we're going to do. We are going to learn about this function first and then give an illustration as to how exactly we could utilize these functions in the real time. So having mentioned, without any further ado, let me start off with the CEIL function. Now this is a very important function specifically for organizations. Now I'm going to demonstrate how exactly we could utilize this function and what exactly does this function do. So this function actually returns the nearest integer to the fractional number that is presented with. What exactly does that mean? For example, imagine an organization. Say for example, let me give you the basic example. Say suppose if you want to get math.ceil of say 9.4, right? I want this to be printed. So this is the line of command I've given, and I want to get the CEIL. So let me run this. So I've already saved it and I'm running this. So when I run it, you see that I just mentioned to you, it gives you the nearest integer to the fractional quantity that is presented. Now where do we exactly apply this? I'm going to give a demonstration also where this can be applied. Now suppose you're working in a good company. When the salary gets paid, say the employee has to get a salary of say 5,690.9, say this is really basic, okay, say 90.10 cents. Imagine a situation is like this. So what do you think people will do? Let me just get the CEIL of this. The employee salary is $5,690.10, and the payment has to be made. So I'm going to get the CEIL of this. Print salary equals command math.ceil of salary. Right? So I've saved it and I'm going to run it. You see that it gives you the nearest integer. Instead of giving the employee 5,690.10 cents, the salary is 5,691. You are able to understand how this application works, because we cannot be giving cents and dimes to employee. Of course 90 cents, giving 90 cents is not much, but it also shows some level of respect, right, on the part of the employer. Of course 90 cents, people might say that 90 cents is small money. Of course it is small money, but if you were to give 90 cents to 9,000 people, then it's a different case altogether, right? But still, that 90 cents gives a rounded feeling to the employee who is getting the salary. So that is the small illustration how exactly the CEIL function works. Okay, so let me comment this off. Now, having got that CEIL, let me give the illustration for the next function. It's called as copy sign. Now, what does this function do? It's a built-in function available in the math module. Now, let me give an example of this copy sign. So I'm going to actually say print math.copysign of say 9 comma minus 3. Now, when I call this function, the value of 9 will be printed with the sign of the number 3. So I'm going to save this and I will show you what happens. You see that 9 is printed with the sign of 3. Now you might be wondering, where do I use this? Okay, let me give you this beautiful illustration of where exactly this particular function is used. Say you are designing an application for an electric car. Say you are designing an application for an electric car. Now this is a scenario, right? Let me give you the scenario. When the speed is say 60 miles and the gear, this gear has the ability to toggle. Say toggles, you can either say toggle stick or toggle gear, something like that, depends on what you like. Now in this toggle gear there are two options. The first option is drive and the second option is reverse. Now the driver wants to drive, or driver wants the car to move at 60 miles in the reverse gear, right? Reverse gear means the driver wants the car to move backward at the same speed, 16 miles. Now you might be wondering, what 16 miles, why is it really required? Now in the real time there are states, or I would say there are situations where it becomes required that the car has to move back at this rate. So there can be plenty of situations where you are driving. So imagine a bear jumps in the middle of the road, right? You have to go back, and at that time all you got to do in the electric car is to change the gear. In the electric car, it's not that you have to use the actual mechanical gear. That's a different scenario, but you will have to just press buttons, right? So the question is, if you have a choice, if you choose reverse, this data has to be passed. That's exactly is the idea. So I'm going to demonstrate how exactly we can do that. So with a small program, right? So I'm going to ask speed. Speed is equal to int, right? I don't need. I'm typecasting here just to be safe. Okay, please enter the speed. Right, this is the question. Please enter the speed. The speed is got, and then gear. Gear is equal to input. Please enter the gear. When I say gear, I'm actually pressing in the button, right? Please enter the gear. So in the gear, you can say forward or reverse. So this is actually got. Now after getting these two things, I'm going to check if, instead of saying capital, I'll just say G. So if gear is equal to, say, reverse, gear is equal to reverse, what we need to do is I will actually give the following: outprint with the action. The action is going to be math.copysign, and it's going to be speed, comma, gear. Now I need to capture the sign, right? So in this case I need to say gear is equal to -1, or gear action. Then I'll pass it here, gear action. Okay, that's the code. So I need to place a comma here. Okay, that's fine. Now else print, I would just say, I'll copy that, else gear underscore action is equal to +1, and print this, right? So this is the app that would listen to the driver, and based on that it will actually send in this information. This information will be an input to the action that will be committed, right? But we are only dealing with one side. That one side is writing the code using the math operator. So that's fine. So I'm going to save this. So after saving it, let me run it. So enter the speed. The speed is 60 miles. Please enter the gear forward or reverse. I'm going to say reverse, and then you see that, please enter the gear forward or reverse. I've entered reverse, and the action is -60. When it says -60, the car will be moving backwards at the rate of 60 miles per hour. So this is a beautiful illustration how exactly we could use the math function. So having given you this illustration, it's time for us to move on with the next one. So we have finished CEIL, we have finished CopySign. The next is absolute number. So let me comment this off, and I'm going to show you the next sign. So the next function. So this is going to be returning the absolute value of a number. So this is called as fabs. This function is fabs. And what does it do? This will return the absolute value of a number. Now you might be wondering, why do I need this? Is it really required for me to enter an absolute to get an absolute value? Of course. Where do we use it? We use it when we are calculating area or mathematical problems where we do not require negative values. We don't need negative values at all. Sometimes it so happens we are forced to produce or perform an operation which will result in a negative value, but we cannot use that negative value. In other words, we don't want the negative value to be present, right? We need to get an absolute value. Now, for example, imagine this is a scenario. Imagine there is a person who has an account in a bank, and what he does is he withdraws all his money. He withdraws all of his money. Now he wants us. Now there is a situation where he wants an overdraft. Now, what exactly overdraft means? The bank will give you money. Will give the person the money based on the trust he has built with the bank. Okay, it's all based on trust. So if the bank manager is happy with this person, he will give a overdraft. Now actually the overdraft is a negative value, okay, but we cannot display the negative value. This negative value is the information for the bank to understand, but when the customer is given this information, that information should be a positive value. So let's see how it goes. So I'm going to say overdraft borrowed or overdraft amount, something like that, is equal to input. Please enter the amount that the bank has given this person. Right, this is the amount. Now I will do typecasting because there might be a situation where we need to perform some arithmetical operations. So this is the amount that is being given by the bank. So current amount or current balance is 0. Current balance, you can simply say int input, say please enter the current balance of the client. So this is the current balance of the client. Now what we need to do is, from the current balance, this overdraft has to be taken out, right? Because he owes this money to the bank, but we do not know what's his current balance. Let us have this scenario, right? So we have to perform the calculation here. The amount owed to the bank is equal to current balance minus overdraft. This is the amount. Now we need to print here. Print you owe the bank this amount, right? And I'm going to display that. So I'm going to call this math dot absolute value, FABS, and then whatever amount owed by this person, owed to the bank, that will be printed there. Okay, so in this case, this is for bank reference. Bank reference is equal to amount owed to the bank, and then print message to the bank. So this message will not be visible to the client, so this is just visible to the bank. So message visible to the bank, and what is the message? The client has outstanding amount. So what is that outstanding amount? In outstanding amount, you got to give this bank reference. So this will not be visible to the client. So this is just for the bank's reference. Okay, so I'm just saving it. Now if I run this, let me run it and show the outcome to you. Please enter the amount that the bank has given the client. Say this client wants $5,000, so 5,000 is given. Please enter the current balance. Say current balance of this person is, say, $0. There's no money in his account. So clearly you see, message to the bank, the client has outstanding amount minus 5,000, and this is to the client. You owe the bank this amount, 5,000. You understand how this absolute value functions? So this is how it functions in the real time. But this application is not restricted to this example alone. There are plenty of cases where this would come into play. So this is just for your understanding. Okay, so having got this, let us go on to the next one. The next one, let me comment this off and give you this next application. So now we are going to talk about this all important factorial function. Now factorial function is very important, especially in data sciences, right? Without factorial you cannot do anything. Now why do I say data science? Because in factorial we got what is called as permutations, combinations, and a whole lot of statistical probabilities, right? This is a different area, probabilities. Okay, this is a different area of science. In fact, it has now become a full-fledged science. And there, without factorial notation, now in mathematics we represent it like this, exclamation. But in Python, the representation is different. And what exactly does that mean? If I were to say 5 factorial, imagine I'm saying 5 factorial. So what does 5 factorial means? 5 factorial is nothing but 5 multiplied with 4 multiplied with 3 multiplied with 2 multiplied with 1, which is equal to 120. This is how the factorial works, right? But 5 factorial is a small number. In statistics, we usually deal with big numbers, huge numbers. So in that case, we need a utility, a function which allows us to calculate that. So having mentioned that, let me just move on to show you how the factorial works. Now, this is straightforward, so I would like to keep it straightforward. Say, for example, you want to print the factorial of, say, 5 factorial, say 5, right? Now you save it and you print it. So you get 120. Now imagine you want the factorial of 6. You get 720. Now imagine you want to get the factorial of 10. You see that? See the number, how the number is increasing? Imagine you want to get the factorial of, say, 19. You will see the jump is huge. You see that? So that is the power of this particular function. It's a very powerful function, and we have to be glad that we are in a position to utilize this function. Okay, so the next function, specifically in Python, so that would be an apt way to say, because if we were to calculate 19 factorials by hand, we would just spend the next 2 days or 3 days simply calculating factorials, because we are not going to just be encountering one number. There would be several dozens of numbers that we would have to deal with. Okay, so having mentioned that, let me go to the next function. The next function is called as the flow function. So what does this do? This gives the greatest integer that is less than or equal to the number that is in context. Okay, so this illustration you will find it in the supermarket. Now suppose you have to pay, say, $21.23, right? And you do not have a change, so you give $100 to the teller. Now the teller has to give you the change back. It's not going to be easy. You cannot simply say as a supermarket that you pay me using a credit card, or you pay me using your, what do you call, the mobile wallet and stuff like that. Because as a supermarket, not everybody are going to be having credit cards, or not everybody are going to be having a mobile wallet, right? There is always the section of the society which don't prefer that. That's one situation. Number two is which are not in a position to use these gadgets and devices, right? One is the by choice, and the other is the inability, right? That inability should also be taken into account. There is that element of a big gap that has to be addressed. So as supermarket, we have to cater to everybody's requirement. So imagine a situation is like this. So the charge is $21.23, and the woman is paying, the young lady is paying $100. The teller has to give the change back. Now giving change back to one person, you might say, is okay. What big deal? The person can give in how much? 77 cents back. But imagine the situation. The person has to give for 10 people like that, or 20 people. In supermarket, at least 500 people, they will come like that. So what would be the situation? And not everybody are going to be paying cash. So that is also that element that is in place. So what we do is, as a supermarket, instead of taking the 23 cents, we design the application so that only $21 are taken. That is exactly what I'm going to show you here. So let me write a code for that. Okay, so this is the code for that. Code is amount spent is equal to int of input. This is going to be float, right? And over here, please enter the total amount spent by the customer. So this is the total amount. We are getting it. Now, amount received. So this is the received amount. So this is going to be int, or if you want float, you put in float. Input. This amount is got from the customer, right? Please enter the amount got from the customer. So this is got. Now we need to only give, or we need to take only the closest integer. So what we need to do is amount paid, to be paid, is equal to math.floor of amount spent. Amount due is equal to amount received from the customer minus amount to be paid. Okay, and then change due. We got to print the change due. So change, we don't have to say change due. We can simply say print change to be given back. This is equal to amount due, right? That's it. Story done. So this application will handle anything that comes in decimal format. So I have saved it. Let me run it. So if I were to run it, the customer is spending $23.21. Amount, the customer is paying $100. You see that change to be given back 77. You have to just give the customer 77, and the goods is rounded off to 23. Probably you can simply say the amount that has been rounded off, right? Print the price that has been rounded off is equal to, give a comma, and then amount to be paid, right? So you save it and you run it. This would be giving you much clarity. So amount, say 23, amount spent by the customer. Of course there is some check error, some grammar, I wouldn't say, some spelling error, vocabulary is there. I need to rectify it, but this is just an illustration. So I will do that if I'm developing a full-fledged application. Enter the total amount spent. Probably I will just change it. It looks a little bit odd. And enter the total amount spent by the customer. It's better. Grammar and spelling, we need to be careful when we're designing applications, because we are designing applications for the entire population of the world. So we need to take some efforts. Of course there are situations where some little bit slight typo error can occur, but we need to rectify them. We need to be straight in all these presentations. So having mentioned that, let me just move on. Okay, so I save it, I run it. So if I run it, 23.21, amount got from the customer $100, and then you see that the price has been rounded off to 23, and change to be given back is 77. So that's fine. So that completes our today's lesson. So we will continue this class again, and this is the first part. The second part will follow on. Thank you.